Welcome back to Educator.com, Introduction to C++. Today we're going to be talking about how the computer and the compiler keeps your data in memory. Okay, we need to keep variables and identifiers, which are also called names. We have names for all sorts of different things. In particular, we'll have names for where a particular bit of data is stored. We'll talk about how those identifiers are put into your system, some styles for how you spell your different names, different things. We'll talk about the simple data types today. Later on, we'll talk about more complex data types, but today it's the simple data types. We have the literals, numeric literals, like 1, 2, 7.5, character literals like Alvin, or just the single character such as the tab, string literals, which is basically, actually this was a string literal here, this is a series of characters, and variable type declaration. We want to have a particular variable, we want to give it a type. Unlike some languages that you may have been exposed to, you might have seen before, C is C++ is a strongly typed language, and once you give a variable a type, it stays in that type. You can't just change it willy-nilly. And how we initialize the variables. All right, now the compiler for C++ requires identifiers to identify various objects, in particular variables, structures, objects, etc. Identifiers are names, and they a name may contain any combination, almost, of letters, underscore, and digits. You can't put plus signs and minus signs, punctuation, exclamation points. Now, one of the restrictions are the name must begin with a letter or an underscore. So here's some valid identifiers here. We have Billy, have Ice 9, we have underscore 42, Ice Truck, Ice Cream. These are all valid identifiers. These are not valid identifiers. This is more like a cartoon cursing here. 17, that's a numeric literal, as is -12. For me, it may be for you or for me, but you can't start it with a digit. You and I has got spaces in there. You can't have spaces inside your identifiers. And here's a special character, the @ sign, which makes for a very nice email address, but not a good variable. Now, some language, it doesn't matter if you have uppercase or lowercase. In C and C++, the case matters. All these variables are different. You can put Fred equals 1, Fred equals 2, Fred equals 7.3. Now, you confuse people doing that, but the compiler will let you do it. So basically, just keep in mind that your capitalization should be consistent, and don't try to do these kind of fancy tricks, because you'll cause heartburn. Now, some identifiers, you can have any combination, but it cannot be a keyword. Certain keywords include int, while, for, bool. There's a long list. And I wouldn't worry about what that list is right now, because you will learn what they are as we go through the class. And if you use something improperly, the compiler will flag it as an error. Now, how do we name an identifier if it's going to have more than one word in it? We've got like ice cream, that's 2 words. Ice cream. Now, there's a couple of schools of thought for how you do that. Some people like to use the underscore. So we've got ice, an underscore, cream. Rocky road, cookies and cream. See, we've got the underscores here separating the words, because this particular variable has some meaning in the system, and it happens to be something with more than one word in it. Another school of thought is capitalize the first letter of each word. So we have ice cream, the first letter of the word cream has been capitalized. Rocky road, cookies and cream. The compiler doesn't care. Use whichever way you want to do. Just keep in mind, you've got humans who have to read the code. So pick a style for your human readers. Stick with it. Stay consistent, because you're human. You don't want your humans to look at it and say, well, what is this guy doing? What's going on here? You want the humans to understand the code that you write. If you're working for a company and they have a particular standard, follow that standard. If it doesn't have a standard, you might want to think about setting one up. But if you see a bunch of code and they're using different standards, you're doing different ways, leave it alone. Don't break the budget. If you happen to have inconsistencies, don't worry about it. Don't fix something that's not broken. So here's some typical styles. Variables starting with a lowercase. A variable such as, for example here, weight equals 200. So we started with a lowercase variable. We have weight, we have height, we have total amount. It has to be equal to something. You work some calculations to figure out what your total amount is, add all your different amounts are, and keep a variable called total amount. Adjusted price, you add taxes, what have you. Very often you write functions, and you'll start those with a lowercase, and they will be verbs because the function is doing something. So we want to calculate the price, that's a verb. We want to get the next object. You want to display something on the screen. So your variables that contain a data tend to be nouns. Your functions that do something tend to be verbs. Not always, it's just a tendency. When you have classes and types, it's typical to start them with an uppercase letter. So we have an employee class, which defines a class of variables, defines an object for object-oriented programming. Transactions start with a capital T. Automobiles start with a capital A. Now, you don't necessarily have to do this. In some places, they will also have those with lowercase letters. But these are just some styles that are very typical that you might want to adopt or not adopt. Constants tend to be in all uppercase. So we have pi as a constant. We hope it's never going to change. The maximum number of rows that you're allowed for something, path, mass. If you have a file name, it has to be a certain path to get that particular file. You have a maximum number of letters in that path. And these are all things that they're not necessarily defined in the system, but you may define them in your system. Now, if you have a company standard, use the company standard. If you don't, like I said, you might want to set one up. If it's too much hassle to set one up, then just use one for your own code. It's usually a good idea if each programmer on the team adopts the same style, but it's not necessary. It's just different things to think about and discuss with your team members.